Good morning, everyone. It's a great pleasure to be here and talking to you all. My name is Ilja. I'm a research scientist at Infusion. And today I wanted to talk to you about unleashing medical innovation, how we get from ideas to clinical impact rapidly. So maybe to start off, a quick few mentions about who we are. So we're a company based in Munich. We consist of currently 41 people, and mostly academics as well. So we have very close ties to academia and also like to publish and visit companies and conferences as much as we can around the world. So here you also see a photo of the whole team and also a photo of my colleagues and me at last year's MIDL in Zurich. So efficient R&D. Let me quickly give you a glimpse of our portfolio and what we work on. So we cover a lot of different things, starting of course from the basics, something like segmentation in CT, fairly standard. But then we also have use cases for robotics. We work on more complicated setups like 2D and to 3D registration. We also do computer vision, for example, SLAM and 3D reconstructions. We also work in intraoperative settings where we have surgery guidance in real time, in this case, for example, for biopsies using ultrasound. And then we also do a lot of registration, even multimodal ones, such as this one, where you can see a ultrasound sweep being registered to an MR image. We also do, for example, vessel reconstruction from ultrasound sweeps, and even the newest addition to our portfolio, thanks to my colleague Max here, is monocular depth estimation. So we do all of these things, and if you paid attention, you remember that we're only 41 people. So the question is, how do we get all of this done? And the answer is that we try to always keep a core of libraries in C++ to make them performant, and we always try to, whenever we work for customers and work on their projects, to bring back the expertise and add it to our toolkit. And from this toolkit, since it's written in C++, it's very performant. We also implement a lot of stuff in OpenGL, so you can run it on the GPU for even more performance. And on top of that, we can build different tools. So the foremost among them is the Infusion Suite, which is a GUI interface for easy experimentation, rapid prototyping, where you have access to all of our tools, just the whole range that I showed you before. And for more specific needs, we also have Infusion Labels, where, for example, here, the goal is to quickly annotate and manage imaging databases. We can annotate, in this case, you see, for example, a spine CT, but we also support ultrasound, MRI, 4D data. And the good thing about this is, since we have this SDK, you can easily extend it. You can write your own C++ plugins. So maybe a quick show of hands, who of you is confident using C++? Yeah, okay, a few people. But we got you covered. We also have a Python SDK. So you can also use all of these tools from Python, and you still get the same performance. Also running on GPU, and it's fairly easy. So here you see a quick use case where you can load data, manipulate it, write it out. And then, of course, since we work a lot with customers, they can use our tools and algorithms and expertise to quickly create a prototype and then integrate that into their own apps. So to give you a quick demonstration of how this looks like in practice, I thought we could talk about spine. So spine is a very rapidly growing market. Last year it was estimated to be $13 billion and expected to grow at a rate of 5%. And this is just the medical device market that I'm talking about here. And in our work, we had a lot of customers who were facing problems in the surgical planning phase for spine. So for that, we developed a whole new suite of algorithms. But we were able to reuse a lot of what we already had in our toolbox. So I'm going to show you here a few demonstrations of what we have introduced in the last year or so. So starting on the left, we see a video of our new spine plugin, where we have integrated all the capabilities that we have for machine learning model inference, rendering, visualization, key point localization, to create a new set of tools that lets you easily localize and segment vertebra with essentially just one click, since we had the in-house expertise for training all of these models. And then we could, of course, rely on all the tools that we had for, visualizing them in a nice way, making everything interactive. So here you can see how that would look like. And the cool thing about this type of data that we're showing is that you have a global orientation for the spine, but you also have individual orientations for each vertebra. So that lets you manipulate the whole mesh and allows us to do very precise mesh-to-mesh registrations, which we also already had. So we just had to kind of come up with the data type to make use of all of the algorithms that we already had. And in this case, I'm showing an example of how this would look like if you're trying to register the spine that you get from a patient to a template spine in this case. And you can even interpolate between them, and mesh registration, of course, being much more precise than just working on voxels. But it doesn't stop there. We can also reuse the same functionality within our labeling software, Infusion Labels. And we can even add a few twists. So here you see the UI of Infusion Labels, where you can also, with one button, localize all of the vertebra, which gets you started in spine projects very easily. And once you have them localized, you can, of course, manually intervene. You can remove vertebra. You can add new ones if you want. And once you have the localizations, you also see that they're all classified. So it will tell you which one is, for example, the L5 vertebra. And you can also segment them. You can even interactively work with the model by providing what we call hints. In this case, it's kind of like a conditional segmentation where you can say this was over-segmented or this was under-segmented, and the model will then reevaluate the segmentation and incorporate your hints. Or if you just want a quick start, you can also just hit segment all, and then you see that we, actually, yeah, that's coming up. We also segment the ilium and the sacrum, but here you see the segmentation of all the vertebra. And then, yeah, then you have a good starting point. You can still modify the annotations if you want, but this lets you really easily get up to speed if you're trying to create your own data set. But once you have your data established and also your, you've experimented a bit with your data and how you want to set up your pipeline using Infusion Suite, you can easily test it out on a bigger set of data using our Python bindings. So in this case, we also added Python bindings for the spine data types. And here you can see a very simple example where you load in some data, which is the first block. You can use the spine-based algorithms, which are also GPU accelerated, which is the second block. And then you can even get all of the information that is stored in the data, such as the vertebra orientation. And yeah, then you can just start from there and build in your own pipeline and try it out, how it looks on a bigger data set. As I mentioned earlier, we also do research. And one of the big issues that we faced when working with spine is the matching of the key points. So what you see here is one of the usual problems that you face when you localize the vertebra. You get a set of points. So in this case, this is the image on the, I don't know if you can see my cursor, probably not. Yeah, so on the lower, the upper left, you see the key points. And all you know is the type of the key point. So you know, is it a vertebra body, left pedicle or right pedicle? But you don't know which set of 3 key points belong to the same vertebra. So the usual solution to this would have been something like Hungarian matching, which is very established and works well on healthy cases. But the ones that we're interested in are usually the pathological ones. So in that case, you often have false positives, as indicated by the red lines here, and also sometimes false negatives. So internally, we worked on a tool based on graph neural networks to solve this issue, and this will be a paper that we'll be presenting at MIDL this year, so look forward to that. But the cool thing about this is that going from research we can actually, since we have all the capability for running machine learning models, we have all of the algorithms to work with spine, we have the visualizations, we can actually just drop this into our suite, and just make use of this. So the user wouldn't even know that something changed, but you get better performance all of a sudden. And just to reiterate the point of making use of what we have, since introducing this spine data type, which is this mesh-based spine with the individual vertebrae, we also started extending this concept to other organs, to other anatomies. Because as you all know, total segmentator is very popular in the recent months. So it's very easy to segment a wide variety of organs. And creating meshes from that, of course, leads to enabling us to also use the mesh-based registrations for those organs. So thank you for your attention. We also have a booth next door if you want to see for yourself how our products work. You can also just reach out to us if you're curious about anything. I'm here with my two colleagues, Max and Stefan, who are sitting here in the almost front row. And yeah, you can also get your own demo version online if you want. So thank you for your attention and hope you have a great rest of the conference.